तो देखिए वही है मेन थिंग इज ऑफ द फॉर्म. इफ यू attended the last lecture part, I think it was part
2.
2, no? Yes, part 2. So part 1, part 2, this is part 3. Okay, so we have real numbers. This is real numbers part 3. So we have seen what we have seen in part 1. A is equal to bq plus r, correct? This is what? This is Euclid's lemma. So Euclid's division lemma says that A is equal to bq plus r. You can write in this form. So we have seen 5. If you remember that, we have seen 5 can be divided when 5 divided by 3. So we can write 5 into 3, 1 is 3 plus 2. If remainder is 2, we can write 5 is equal to 4 into 1 plus 1 when remainder is 1, and we can write 5 into 1 plus 0. So you can see 5 can be written in these 3 forms. But when you are dividing by 3, you will get this form. That is another thing. So we are dividing. So we can write any number in this form. These two differs. These two values differs, but this will not differ. You can see that. So similarly here 6q plus 3, 6q plus 5. So we have given the quotient 6q. Instead of writing here, they have written quotient here. We are dividend into quotient plus remainder 1. 6q plus 1, 6q plus 3, 6q plus 5. So as I told you, r varies from 0 to here. Here 2 is the maximum value. So r varies from 0 to 2, 0 to 2, greater than equal to 0 and less than equal to 3, less than equal to. So r is always greater than equal to 0 and less than equal to b. So this is the Euclid division lemma. So just do not worry about this question. Very simple question here. So whatever format is given, that means this form is now try to understand. This is the form of 6q plus r, correct? R is the remainder. Different remainders are given. This question is of the form 6q plus r, correct? Understood? So we will, when whatever form is given, we will suppose that the given integer is of the form this one. So let, how we will start this type of questions. Let a is equal to 6q plus r be a positive integer. Where up now, can you tell me where r will vary from? R will be equal to greater than equal to 0 and less than equal to
B. B. 6.
B.
Less than 6.
less than equal to
Divisor.
6.
6.
3.
6. 6. This number.
6.
This number. There is only one number here. Huh? So
Yes,
this
sir.
less than equal to this number. Yeah, B. You can see here B. R is less than equal to B and B is here. A is this. 6 is B here. Here 6 is playing the role of B. Okay. So we will always suppose whatever form is given that we will write A is equal to 6q plus r be a positive. Now here r varies from 0 to 6. That means r values of r are 0. It can be 0,
0, 1, 2, 3,
1,
4, 5.
2, 3,
3, 4,
4,
5,
and
and
5.
5.
5. Hmm.
Okay.
Yes, sir.
So now we will. The question is any positive odd integer can be written in the form. So any positive odd integer. We have to check the odd
1,
integer.
3, and 5.
Positive integer. So we will write positive integers. First we will see that how many we can, when now we will check when r is equal to 0, when r is equal to 0, a will be equal to what? 6q, correct? A will be equal to 6q. Just put the value of r.
Yes, sir.
Just put the different values of r here to get the value of a. And 6q will be equal to q is any integer. Q is any integer. And when you multiply an integer with 6, it will become even number because you are multiplying with even number. Even, it will be an even number. When we put r is equal to 1, then a will be equal to what? 6q plus 1. Correct? And 6q plus 1 will be what? Odd. It will be
Yes,
an
sir.
odd number.
7.
Because odd 1, we are adding 1. If you add any number 1,
Yes,
if
sir.
it is an even number, 6q is an even number. Suppose 4 is an even number. If you will add 1, it will become odd number. So 6q
Yes.
is an even number. If you will add 1, it will become
7Q.
odd number.
7Q.
Okay. And
Yes,
when
sir.
r is equal to 2,
Sir, your
So you're
mic is
mute.
off.
So
Sir,
you're
your mic
mute.
is off.
when r is equal to 2, a will be equal to 6q plus 2. So a is equal to 6q plus 2 is an even number again. Why it is even? Because 6q is an even number. Adding even 2 in the even number, it will remain even number. Are you understanding? Then r
Yes,
is
sir.
equal to
Clearly.
when r is equal to 3, a will be equal to 6q plus 3. 6q plus 3 again it will become odd, which is an odd number. You
Yes,
can
sir.
write which is an odd number, but I'm writing in short. So r is equal to 4. When r is equal to 4, a is equal to 6q plus 4, which is an again even number. When r is equal to 5, a will be equal to 6q plus 5, which is an odd number. So see that when we are taking odd number, this is also 1 is what? Odd. And this is also odd.
Sir, is 6q a common number in this one?
Yes,
Okay, sir.
Of course not.
odd. Okay, 6 is always there. So odd. So odd positive, any odd positive integer. So any odd positive integer, this is the odd positive integer, is of the form, either it will be a, this is not required, I think. This is, do not write r. So a is in the form of odd number, then this will be 6q plus 1. You can see 6q plus 1. When it is odd, it is in the form of 6q plus 3. 6q plus 3. When it is odd, it is in the form 6q plus 5. So any positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Means it can be written in the form. It will be always in the form of this one. So this shows that any positive, understood? Any positive odd integer means any positive odd integer can be written in this form. For example, you write any positive odd integer. Suppose you are writing odd integer 21. So if you want to write in this form plus 1, okay, and with 6, so 6, 3, 6 4 the 26, 3 the 18, 6 3 the 18 plus 3, 21. So you can see 6q plus 1. This is which form? 6q plus 3. Okay. Any number, any odd number, if you take any odd number, suppose 5, no, 5 is less than 6. So greater than 6, we have to take 12, suppose 12 or 13, sorry, 13. Because 6 to the 12 odd number, we have to take here odd number. These are odd numbers. So any odd
6 to
number
the
can,
12 plus 1.
Yes, 6
6
2s are
into
12
2
plus 1.
plus 1.
You can see
Yes.
that this is in the form of 6 cube plus 1. So if you will take
Yes,
any
sir.
odd number, it will be out of these three forms, none other than this form. So any positive odd integer is of is always of the form is of the form. This is proof that is of the form 6q plus 1, or it will be 6q plus 3, or it will be 6q plus 5. So if you will take any odd integer, you try to write like this always, you will find r is equal to either here 3 will come, or 5 will come, or 1 will come. Okay, 1 or 5 can come. Got it? This is the, so
Yes, sir.
in
Clear.
general, in short, you should, in short, you have to start the question by taking a is equal to whatever the form is given. Then you have to check what number is given with q. So r value of r will vary from 0 to 6. So you will take the value of r from 0 to 5. Just put the value of r one by one, and you will get the answer. That's very simple. Got it?
Yes, sir. Yes,
Yes,
sir.
sir.
But there are some questions are having, that there are some problems in some question, but here there is no problem. In question number 4 is the same that we have done just now. So we will take this question also. So here, using Euclid's division lemma, show that now this is not the simple one that odd positive or negative integer. Square of any positive integer. What? Square of any positive integer is of the form. Now square of the any positive integer is of the form. So this question also we will start by taking, this is the form, although it is the square. Okay. So we will square of that integer will be of the form this. So we will take 3q plus r. Here also we will take the 3q plus r. So let a is equal to, but we have to prove their square will be 3m or 3m plus 1. So let a is equal to 3q, let a is equal to 3q plus r be a positive integer, where r varies from 0 to less than 3.
3. Yes, sir. 3.
That means the value of r will be equal to 0, 1, and 2.
2. Yes.
Okay. So in the first condition, when r is equal to 0, see this question, this is square, because of the square it differs. So when r is equal to 0, a will be equal to what? 3q. This is the positive integer which can be written in form of 3q, but we have to find the square of this number. So that's why here in every question you have to, in every part you have to square. So now squaring both sides. These both sides are squared. Squaring both sides, we get a square is equal to 3q whole square. 3q whole square, that is 3 into 3 into 3,
9q, sir.
3q square. Now we have to find, we have to write in the form of 3m and 3m plus 1. So this 3q square we can replace by m. So this is any number, so 3m. It can be written as 3m, where m is equal to 3q square. So 3q square is replaced by m. Okay, 3q square is replaced by m, so it can be written 3m. So now it is proved that the square of this number can be written in the form of 3m when r is equal to 0. So whenever a square or cube is given, we will have to square and then convert into this form. M is for some integer, where M is any other integer. Understood? When R is equal to, and when R is equal to 1, then A will be equal to 3Q plus 1. Okay. And then squaring. Squaring will be equal to A square is equal to 3Q plus 1 whole square. So A plus B, 3Q plus 1 whole square. So A plus B whole square is equal to A square plus 2AB plus B square. A square plus 2AB plus B square. So we can write A square means 3Q square plus 1 square 1 plus 2 3 is 6Q. Okay. So 3Q square will be equal to 9Q square
9Q square. Yes, sir. 9Q square.
plus
Plus 1
6Q
plus 6.
plus 1. And this can be converted into 3M plus 1. So 3 is common. If you take 3 common from these first two terms, so 3 3 is a 9. 3Q square plus
Plus
2Q.
2Q. Yes, sir.
Don't take Q common because we have to convert into 3M. Then this is replaced by M. So here can be written, it can be written 3M plus 1, where now this M is different, where M is equal to, M is some integer which is equal to 3Q square plus 2Q. So see that this is converted into 3M. Similarly, the third one, when R is equal to 2, when R is equal to 2, when R is equal to 2, A will be equal to 3Q plus 2. Okay. And squaring both sides. So we get 3Q square means 9Q square plus 2 to the 4, 3 the 12, Q plus 2 square 4, A square plus 2AB plus B square. Okay. Here you have to see that how to convert into this form. So this 4, you have to split this 4 into 3 and 1. So 9Q square plus 12Q plus 3 plus 1. 4 can be written plus 3 plus 1, correct? So this part you have to separate. Why? Because we have to convert to 3M plus 1. 3 is not common. If we take from 4, we cannot take. So now 3 cannot, now 3 can be taken common. So 3 3 is a 9.
9,
3
4,
Q square
and 1. Yeah, 3Q square plus 4Q plus 1.
plus 1 plus 1.
Plus 1.
And
Okay.
it can be converted into the format 3M plus 1, where M is equal to
3Q square plus 4Q plus 1.
Q square plus 4Q plus 1. So it is proved that the square of any positive integer is either of the form 3M or 3M plus 1 for some.
Sir, it should be 3M plus 2, right? R is equal to 2. You wrote 3M plus 1.
Question number 5. Let A is equal to 3Q plus R. Here we will take 3Q plus R, not 9. And R, this you have to remember, R varies from 0 to less than
Then 3.
it is
1 and 2.
R will be equal to 0,
0, 1 and 2. Yes, sir.
and 2. The first condition, when R is equal to 0, A will be equal to 3Q. Now we have to find the cube, taking cube on both the sides. 3A cube and 3 cube.
27.
3 3 is 9, 3 is 27. So we will write
27
9
cubes.
into
Sir,
9 into
9,
3 Q
sir,
cube.
9 3Q cube.
Yes, 9M. 3Q cube is what? M. So where M is equal to
3
M
m
equal
equal
to
to 3q cube.
3q
Yes.
cube. 3q cube.
3q cube. Yes. So M is 3q cube where, so it is converted into 9M. Okay.
Yes,
So
sir.
when we are taking R is equal to 1, when we are taking R is equal to 1, so A will be equal to 3q plus 1,
Yes, sir.
correct?
Correct.
Taking cube root on both the sides, so A cube will be equal
Yes.
to 3q plus 1 whole cube.
The whole
What
cube.
is the
Yes, sir.
formula of A plus B whole cube? Abrar, fast.
सर ये तो पता नहीं
So A
लास्ट
cube,
ईयर तक ध्यान नहीं
A
दिया
cube plus
So a
B
cube plus
cube
b cube into 3a square b plus
plus 3 A square
3a
B.
b square.
Yes, A square B plus 3AB square. A cube plus B cube plus, now 1 is also there. So this 1 will be taken outside, and in all other terms we can take 3 common from this 9, sorry, not 3, 9 common. If you take 9 common from this, so this is 27. So 9 3s are 27, 3 u cube plus from this 9, 3 3s are 9, here also 27. So 3q square will be left. Here q will be left. Understood? Plus 1. And this is m, so we can convert into 9m plus 1, where
m equals to 3q cube plus 3q square plus q
yes,
plus
m is equal to 3q cube
plus
plus 3q square plus q. And
yes
the last,
and plus
when is r is equal to
2
2, a will be equal to 3q plus 2, and whole cube, its whole cube will be equal to 3 cube, 3q
plus
cube, a cube plus 2 cube plus 3 into 3q square into 2 plus 3 into 3q plus 2 square. So this 2 2s are 4 2s are 8, because we have to bring 8. So this
yes
8
sir
can be written outside, and we can take 9 common. When you take 9 common from this, so 3 is 9 is 27. So 3q cube will be left. From this you take 9, so
3q
q
square
square is left.
square
No, 3q square. 3q square is left, and from
and
this
here
q will
3q
be left. No, sorry, this number 2 to the 4, and here 2 is also there. So 3 to the 6. Here 6 will be left, and here when you take 9 from this, 2, no, not 2, 3, 1 3 will be left, because this is whole square. So 3 to the 6, 6q square will be left. Here 9 will go 2 to the 4, so 4q is left here, plus 8. So this can be replaced by m. So 9m plus 8, where
m equals to 3q cube plus 3q square
m
plus
is
q
equal to 3q cube plus 6q square plus 4q.
yes sir
Now at last also write, therefore the cube of any positive integer is of the form, hence prove that cube of any positive integer, this sign, the cube of any positive integer should be written at last is of the form 9m plus 1, 9m plus 8.